Good morning, everyone. My name is Daryl, and I'm from SMK Damansara Utama. The name of my project is called Evaporative Roof Cooling System, an innovative cooling approach to reduce indoor heat with water evaporation. The problem statement is the ongoing El Nino phenomenon has caused a hotter and drier weather in Malaysia, which leads to an excessive use of air conditioners, which leads to a higher electricity consumption. The high consumption of air conditioning leads to a higher electricity bill, which becomes unaffordable. So, the solution for this problem is the evaporative roof cooling system to cool down the roof by wetting the surface of the roof with water, and the water evaporates the heat off the roof. So for the product modules, we have water dispensing, water collection, power supply, and software system. So how does it work? First, the Arduino sensor will detect a high temperature, and it will then trigger the Arduino system to activate the pump. The pump will pump water into the sprinklers, which will then sprinkle water onto the roof to cool it down using the evaporative cooling method, and the remaining water that has not evaporated will flow back into the gutter, which will go into the water tank, and the water will recycle again for next use. The objective of our project is to reduce the roof temperature surface and subsequently reduce indoor temperature to a comfortable temperature, and a more sustainable and cost-effective method to reduce indoor temperature compared to conventional methods, especially air conditioners. For some observations has been carried out to gather data as a deciding factor in order to prove that evaporative concept. The following experiments that are carried out during the project are setting the baseline room temperature, which is to collect a temperature by hourly to get baseline temperature reading. Another test that is conducted is to prove which water dispensing method is best: sprinkling, misting, or streaming. The third test which will be conducted is the duration for temperature reduction to determine the duration used to reduce the targeted temperature. And lastly, when should the system activate again? So based on the observation from a research conducted for 5 days to observe a room, the highest temperature is ranging from 31.9 Celsius to 34.7 Celsius, whereas the slowest temperature cut, whereas the lowest temperature is ranging from 28.9 degrees Celsius to 31 degrees Celsius. In most days, the temperature stays around 30 degrees Celsius throughout the day. The contribution for this project to the community is an eco-friendly approach in reusing water from the water tank. It provides a long-term sustainability and climate resistance, and it also reduces the chance of heat-related illnesses like heat stroke and severe dehydration. And lastly, it reduces the cooling appliances consumption. That's it for my presentation. Thank you.